Alright, this final screencast of our velocity time graphs, I'm going to show you how we can use them to work out the displacement. So in the previous screencast, we learned that it's the gradient of a velocity time graph. The gradient is what tells us about the acceleration. So the gradient informs us about the acceleration of the object. But there's another aspect to this graph which gives us equally useful information, and that is the area under the graph. The area under the graph gives us information about the displacement of the object. I'll show you how that works. So we're using the same graph that we have in the previous two screencasts. So look at section A again. So let's assume it's starting at a particular position, okay, wherever it happens to be. All right. Now for the first 3 seconds, it was increasing its velocity until after 3 seconds it reached a velocity of 3 meters per second. So it was constantly acceleration through that whole time. How far did it actually travel during that time? How far did it travel between the 0 second and 3 second mark? Well, to work that out, we would actually look at the area under the graph. So this area in here will tell us the displacement of the object over that interval. Now, that shape is clearly a triangle, and so the area of that triangle is going to be 1/2 times the base times the height. So it's going to be 1/2 multiplied by, well, the base is from there to there, so the base is 3, and the height is also 3, so it's 1/2 of 3 times 3, which is 1/2 of 9, which is going to be 4.5. Now notice that the answer is also positive, so its displacement is 4.5 meters. So in other words, what that is telling us is that during that first section, section A, it travelled, its displacement was positive 4.5 meters, or 4.5 meters in the easterly direction. So it's now 4.5 meters further east than where it was when it started. Okay, let's have a look at section B. So section B, what happened? Well, it actually started traveling even quicker. It's accelerated at an even greater rate to reach a velocity of 6 meters per second by the 4 second mark. And so I wonder now, what would its displacement be at the 4 second mark? How far has it travelled in total? Well, we already know that its displacement is 4.5 meters during the first section. So in section B, we do the same thing. We look at the area under the graph, or the area between the graph and the x-axis. Now, in this case, we can see that the shape is made up of a triangle and a rectangle. And so we need to work out the area of both of these and then add them together. So in section B, the area, first we'll do the rectangle. It's simply a height of 3 and a base of 1. So it's going to be 3 meters. That section in there is 3 meters. Now, in the triangle, the base is 1, the height is 3. Because it's a triangle, it's going to be half of the corresponding rectangle, so it's going to be 1.5. So that area in there is 1.5. So the combined area of both of those sections in there is going to be positive 4.5. So in section B, it travelled a further 4.5 meters in the easterly direction. So to this point, it's now travelled 4.5 plus another 4.5, so its displacement is now 9 meters east of where it started from. And we can keep going along this graph. So if we want to look at where it would be after 5 seconds, we want to work out where the object was 5 seconds after it started moving, then it would be this section plus this plus this plus this section or this area under section C. And the area of that's simply going to be 6 times 1. So that's going to be 6 meters. So at this point here, its displacement is now 9 plus another 6. It is now 15 meters east of where it started from. Now, let's say finally, or actually not finally, let's say we now want to look at where is the object after 8 seconds. So, in other words, it had been travelling in the easterly direction, it sped up, travelled at a constant velocity for about a second, and then started slowing down. And at this point here, it had briefly, or for an instant, it reduced to 0 velocity. Where is it now? Where is the object at that time? Well, to answer that question, we just need to work out the remaining area leading up to that point, which is in here. And once again, it's a triangle, so we're going to work out the area of that triangle. Its height is 6. Its base is 1, 2, it's got a base of 3. So the area in there is going to be a half of 6 times 3, which is a half of 18, which is equal to 9. And so by the 8 second mark, it has travelled 15 meters plus another 9, so it's travelled 24 meters. So this object, from the moment it started to the 8 second mark, travelled had a total displacement of 24 meters east of where it started. So it is now 24 meters east of where its initial starting point was. Let's have a look at what's going on in section E and F and G. So in here, I'll just use a new page just to avoid some confusion. Whoops. No, I won't. I made a blunder there. Sorry about that. I'll just have to keep that page. So in this section here, in section E, if we want to work out where it is after 9 seconds, we can see that once again we're going to be working out the area of the graph, but notice that this area here is under the x-axis, and so that's going to give us the negative area. And so in here, its displacement would be, let's look at the base is 1, the height of this triangle is in fact 4, so it's going to be a half times 1 times 4, that's going to be an area of 2. But because it's under the x-axis, it's going to be negative 2 meters. So that area there is negative 2. And so now, its total displacement, it's travelled 24 meters in the easterly direction, but now it's come back 2 meters in the westerly direction. So now its displacement at this point is going to be 22 meters east of its starting position. Let's have a look at this section in here. Between the 9 and 10 second mark, it travelled another 4 meters. That's the area of the graph in there. So it's minus 4 meters. So now it's moved back another 4 meters. So where is it now? It'll now be 18 meters east. Finally, if we look at this final section in here, that area is going to be the area of the triangle, which is going to be a half of 4 times 3, which is a half of 12, which equals 6. And so this object has now travelled another 6 meters in this direction. That arrow should be longer. And so where it ends up is in fact 12 meters east of the starting position. So to sum up, what we can see is this object in this section in here, it ended up travelling 24 meters in the easterly direction, and then in the orange section it returned but didn't return all the way because that area is not as big as the initial area. So it only came back another 12 meters. So its final position was positive 24, then take away 12, which equals positive 12. So its final position is 12 meters east of its starting position, or positive 12 meters. So that's how we can use velocity time graphs to determine the position of an object or its displacement. Okay, thank you very much.